As the last topic for today's lecture, I want to talk about static analysis. So that's one of the great features of Marlowe. As Simon explained in the first lecture, there are some trade-offs being made with Marlowe versus Plutus. Plutus is a general purpose language. In principle, you can do anything with Plutus. Marlowe is much more restricted and it's much simpler. So it means you can only write certain contracts in Marlowe. Not everything you can do in Plutus, you can also do in Marlowe. But the big advantage of that is that Marlowe contracts can be analyzed and they can be analyzed statically. I mean, of course, you can also analyze a Plutus contract, but it's much more simple to analyze a Marlowe contract and to get much stronger guarantees with actually very simple analytic tools. And in particular, you can do this so-called static analysis, which means you don't need to run the contract to analyze it. In Plutus, often when we test Plutus contracts, we use something like unit tests or property-based tests. So property-based tests are much more powerful than simple unit tests. There, the idea is that you generate hundreds or thousands of random test cases, throw them at the contract, execute it, and see what happens, and see that whatever happens is according to your expectations. But in principle, in Plutus, you actually have to execute it to see what happens, to test it. Not so in Marlowe. In Marlowe, you can just look at the contract and analyze it without having to run it. And this is accessible here in the playground. If we go to static analysis, and at the moment we see there are like 3 different types of static analysis that are done that might change in future and be combined in like one big report. So at the moment, this is the contract that we ended with in the last section. So at the moment, there are no warnings. There's nothing with reachability. And if we do the analyze for refunds on close, we do get something. It says the following close constructs may implicitly refund money. And then it lists various paths through the contract. So it says we do the let, then the when first case, that's the deposit, and then the second when, that was the choice times out. So this is the case where the deposit is made, but then the chooser refuses to make a choice. So in that case, there will be a refund. And that's true. And that's also by design, because we want the depositor, the giver, to get his money back in this case. So the second is the deposit is made, the choice is made with value true. So that means 1 was picked. The payment happens and then close. And that's also a fact, because the pay goes to the internal account of the receiver. So when the close is hit, the receiver gets refunded. But that's also by design. Finally, this last one here is if choice 2 was made. And again, then receiver 2 gets the money from his internal account. So as it says, this does not necessarily mean there's anything wrong with the contract. So I did it like that on purpose. We could change the contract. If we change the payment here, and instead of paying to the internal account, we directly pay to the wallet. We can do the same in the second branch of the if statement. Let's just change this to receiver 2. So now, if we do this again, these last 2 cases have disappeared, because then in the case where the choice is made, the payment happens directly to the wallet. So when these closes here are hit, there's no money left in the contract to be refunded. So the static analysis sees that. Now, what about warning and reachability? So let's first look at reachability. Though that checks whether there are branches in the contract that can never be executed, that are unreachable. So in our case, we don't have any. But for example, if I change this observation here and instead of constant 1, say constant 3. Remember, the only 2 possible values are 1 and 2. So this should always be false. So in this case, we should never get into the then branch and always end up into the else branch. So let's see whether static analysis detects that. And indeed it does. And it tells us, okay, if the deposit was made and the choice was made, then true leads to unreachable code, which means the true case is impossible. So it will never be the case that this statement here is true, which is true because we know this here is always 1 or 2, so it can never equal 3. Let me change that back. So that's nice. So when you have something like that, that's of course at least a strong indication that something is wrong, that you made a mistake or didn't consider it. Or in the very least, you can, in that case, remove parts of your code and make it simpler. So if I really wanted a 3 there, then I could remove the complete if statement and just replace it with this else branch, because the then branch would never be hit anyway. So now warning, let's look at an example for warning. Let's say I replace this here. Let me first clear this, sorry. Yeah, okay, I just wanted to check. So I set the amount to 50 ADA. So let's say instead of paying amount, I remove this and replace it with some constant value, let's say 100 ADA. So if I now analyze for warning, then I do get a warning and it says partial pay. The contract is supposed to make a payment of 100 ADA from account giver party to the wallet of receiver 1, but there are only 50 ADA. And it also gives me a sequence of actions that can lead to that situation. So the contract starts, then the deposit is made, 50 ADA, then the choice is made for 1, so choice number 1. And in that case, we would end up in this then branch and then hit this payment here of 100 ADA, but only 50 ADA are there. So it detects this problem that we want to make a payment that's not possible in this situation. If I clear this and put, for example, 150 ADA there and do it again, then we don't get warnings. Because in this case, the deposit, the 150 ADA now, is high enough to cover the payments, to cover this payment of 100 ADA. So this is, of course, just a small example of what's possible. There are other things you could check for. You could statically analyze a Malo contract for, but these are already very useful. So you get warnings if there is a payment that can't be made under certain sequences of actions, and you get a warning if there are branches of your code that can never be reached.